Well, thanks for showing up, everyone, and thanks for having me. It's indeed the third time, I think. Maybe the fourth. I think the third time at Mobile Warsaw for me. And today I want to talk about build systems, actually, and how they relate to SwiftUI. So the first bit is more build systems, and then we'll do a bunch of SwiftUI. And I think it's very interesting how they're sometimes very similar. So I don't know who recognizes the syntax here. This is the syntax for a rule in a makefile. And when I think of build systems, makefiles are the first thing I think of. So maybe some are a bit too young to have used makefiles, but definitely like the older ones, including me here, have often used them and played around with them and gotten very confused by them. So this is the syntax. You write a target and then a colon. So the target is the file you want to generate. Then you write a list of dependencies separated by spaces. And finally, the command. And so the command is on a new line, and it's very important that at the start of the new line, there's a tab character. You can forget about that, actually, but that's the rule. And so let's see. So I hope everything will work with the slides. And let me make it a little bit bigger so you can read this. OK, so this is the rule for generating one.html. And we have one dependency, which is one.md. And on the right here, we can see the graph that we create. So that arrow means a dependency, which means that if one.md changes, we should regenerate one.html. With makefiles, you write these dependencies yourself. And so we can continue, and now we can write the command to generate this. And so every time we request one.html, the makefile will see and does it need to regenerate or not? And only if one.md changed in the meantime, it will regenerate. And this is nice, but of course we want to let's say build a static site generator, and for that we would need to generate more than one.html, right? And so we want to generate HTML files for all the markdown files in our directory. So we can change this a little bit. It's a little bit obscure, but the $@ actually in this case will mean the name of the target. And we can do the same thing for the input file. So we can write $. Now it's becoming really unreadable, but more generic. And so the other thing we need to change is where it says 1, we need to have some kind of placeholder. And so for makefiles, that's the %. And now for any file in our directory, it will generate the corresponding HTML file. So we made this a little bit more generic. And let's continue a bit more and generate index.html. I'll make it a little bit bigger, less big. And so for index.html, we depend on both markdown files. You could make this more generic at some point, but just to show the idea. And now we can actually, well, let's write something there, and we can start to look at what happens when a file changes. So for example, let's say one.md changes. Now, if that invalidates and we want to regenerate all 3 HTML files, the dependency graph will take care of this and will only regenerate one.html and index.html because they have a dependency. And so the same if we were to invalidate 2.md, it's the same thing, right? But then it's index.html and 2.html. And so the nice thing about makefiles is that we write these rules and we get an incremental system out. Incremental in the sense that first we need to build everything, but then as we make small changes, if they only affect 1 or 2 files, only those are going to get rebuilt and not everything. And the reason why we do this and not a bash script is because if you have a large build, with a bash script, you need to run the entire build all the time, and with makefiles, you can be very efficient. Okay, so let's continue with the next example. Let's see if I can scroll correctly here. This is maybe already a bit closer to home, Swift packages. Right? And so these are an incremental system as well. And let's add some packages. So let's imagine we have a shared package with no dependencies. We have a server package, which depends on shared. We have a client package, which also depends on shared. And then we have an app target. And in this case, the app just depends on the client package. And this is the graph that you get from that. And so if we were to make a change, so the first time, of course, Swift needs to build everything. But if we make a change, let's say just in the app target, that's the only thing that gets rebuilt. So this is why people put stuff into packages, so you get faster builds, right? Because you don't need to rebuild shared if only the app changed. And likewise, if we invalidate the client package, then of course it rebuilds the client package and the dependency app and so on. And if we were to invalidate shared, it would rebuild the server, the client, and the app. And this is again one of these examples where you write a declarative system like this on the left and you get an incremental system out. And I think that's very powerful because, I mean, who doesn't love waiting for the build to finish? So SwiftUI is actually, or Swift is incremental at the package level and also at the source file level. So it will also do dependency tracking for the source files. I don't know 100% how that works, but there's a link at the end with a good talk about this. Okay, let's look at the next example. This is actually maybe a little unexpected as for incremental build systems, but this is a spreadsheet. And spreadsheets are incremental as well. So let's have a look at this spreadsheet. So we have, oh, this is a little bit hard to read. So we have a dough calculator where you can take the amount of flour and the hydration, and then if you multiply the two, you get the amount of water you need to add to your dough. So in this case, we want 65% hydration, so we just multiply the hydration by the flour, and that's the formula we see here, B1 times B2. And so this cell that we're looking at, cell B3, if we think about it, it has a dependency on B1 and a dependency on B2. And so we can visualize that. And then if we look at the total, that just adds up the water and the flour, so cell B4 adds up cell B2 and cell B3. And so we can visualize those dependencies, B2 and B3. And this is the graph we end up with. And it actually used to be in Excel, apparently, that they would evaluate left to right, top to bottom, anytime anything changes. And they would keep re-evaluating all the time until it stopped and stabilized. And that's, of course, very inefficient. And at some point, they came up with this dependency graph and evaluate in that order. So we can look at what happens there. So if we change, for example, the hydration, so that's cell B1. So let's change it to 0.68. Now cell B1 invalidates, right? And so that means we need to recompute cell B3 and then cell B4. To us as humans, the order is very easy here. To the computer, it's not always. So let's change the flour. So let's change it to 900, and then cell B2 invalidates. And now we have two options, right? Like, so we could go to cell B3 and recompute the result of that, or we could do cell B4. To us, again, it's very obvious that we should first recompute B3 because the final cell depends on it. If you want to ever build an incremental system like this where you need to make these kinds of decisions of what to build first, the key word is topological ordering. So the topological sort is the algorithm you use for that. And so in this case, it invalidates B3 and B4, and it does not recompute cell B1 because that doesn't depend on this. And so, of course, for a simple spreadsheet like this, it does not make any difference, right? It might be even quicker to just recompute everything. But people build very complicated apps in spreadsheets, and it becomes very important that it's incremental. So to me, these are actually the same as the other two systems, right? Like a spreadsheet and a build system is just the same, in my mind at least. Okay, so now finally we got over the build system part. Let's talk about SwiftUI. So this is that same dough calculator, and we can try to change it here. So this is an iOS app, right? So let's change it to some values, everything updates. And now the question is, how would you implement this? And so way back, we used Model View Controller, or maybe some people still do a lot. And so Model View Controller, I guess, is the standard pattern that comes with iOS, the thing that Apple used to promote. And it has one big problem. The big problem with Model View Controller is that you need to make sure that your view and your model stay in sync. If you know that that's the problem, if you're aware of it, you can work really hard and try to make it correct, and probably will still make a few mistakes, but you can actually deal with that. To me, I never really fully realized, like made it verbal that that was actually the problem. But once you know it, you can deal with that. It's still a lot of work, right? And so we've all been there where we need to restart an app and then it works. And it's often just because the view and the model got out of sync. So that's the hard problem about Model View Controller. And actually, we as the iOS community came up with a solution to this after a few years of writing iOS apps. So let's see if I can scroll. And there's a lot of code here. So the solution we came up with was MVVM. Right? We create a view model, and there are different definitions of what that means. In my mind, a view model means that you have some kind of reactive setup that listens to the model and transforms all the model data and gives you the outputs for your view. And I don't know too much about MVVM, and I'm not very good at writing reactive code. This is in Combine. I'm not very good at Combine either, but we'll step through it and see actually what happens here, because it's quite interesting. This hydration subject is kind of like a state property in SwiftUI, right? It sets up a mutable box, and the same for the flower subject. And then we have this combine latest publisher that takes both of these subjects, and if either one changes, it runs the map function, it multiplies the two values, it assigns it to water amount, and then has some bookkeeping. And so this is kind of the dependency graph that we get from that. And if we continue and look at the next one, we can compute the total weight by adding the water and the flour up. So again, it's a lot of code, I think, compared to, for example, Excel, but it does the job. And what I found very interesting is that this graph here is actually the same as before when we did the dough calculator in Excel, except now it's not B1 and B2, but hydration subject and flour subject. And so we can continue. So there's storing the value in the view layer, and the same for the total weight layer. And then you can see how you built this complicated graph of all kinds of stuff that's going on, right? And now we can try to see what happens if we invalidate the hydration. So then that becomes dirty. It starts recomputing the water amount, the water stack, the total weight, and the total stack in some order. And this is nice. It works well. If you write reactive code, you always feel really proud because you did something difficult. But I don't know if we really need to be that difficult. Like for me, it was always too hard. But you can totally make it work. One of the other problems, I think, with reactive programming is that you're not really writing an incremental system because you're still dealing with all these values that change. You need to find the right way to combine values, right? Do you use combine latest or something else? And it's also hard to debug. So this code that we have here, this is just setting up all the reactive bits, right? Like it's not creating views or anything. It's just all the signals and everything. And so now let's compare it to SwiftUI. I'll zoom out. So this is the entire SwiftUI code, right? So that's much shorter, which I think is really cool. This generates an incremental system. And also, it generates all the views and everything, so it's way less code. And so let's look at how this works, because the incrementalness of SwiftUI is a little bit different than in the other systems. First, we have two state properties, and they generate nodes in the graph that can change their values. And then we have these two computed properties, and they are not really represented in the graph of SwiftUI. So on the right-hand side, we can really think of this as the attribute graph, the underlying system of SwiftUI. And so computed properties like this, they don't have a representation in the attribute graph. They're just attached to the view. Now, because we access both the $hydration and the $flour, because we access the state properties, SwiftUI adds an edge here. So anytime you access a state property in the body of a view, SwiftUI will create an edge in the graph saying there's a dependency there. So in this case, our body depends on hydration and on flour, on those two state properties. And even if we weren't using the text fields here, we're still indirectly accessing these two properties through the computed property. And so those edges, they exist in the graph now. And so if we change the hydration value, what happens is SwiftUI will invalidate that node in the attribute graph. It will actually recompute the entire body, so the form, the section, the two text fields, and the two labeled contents. It computes the entire body brand new. And then so that's basically all the nodes below the body. So the incrementalness is there, but kind of at the body level. Anytime a state property changes, it doesn't just recompute a single text field, it computes the entire body. And now let's make it more interesting. So we're going to create a nested view, and in here we're going to have some text, and let's add a property for that as well. And then we're going to use that nested view inside the body of our main view. So we're just going to have some static text there, hello world, right? And so this is a little bit simplified. At the bottom there's the text node and the body of nested, and of course at where the ellipsis is, there's all the other nodes as well, right? Like the form and the section and all of that. So now let's change the hydration value again to 0.59. That node invalidates, the body of our view is executed. It constructs a whole new form, a new section, new text fields, new labeled contents, and also a new nested value. However, and this is, I think, where it gets really important to understand if you want to work with SwiftUI effectively, SwiftUI can compare the previous value of nested and the new value of nested. Previously, the title was Hello World. Now the title is Hello World. They're the same, and SwiftUI can detect this. Because they're the same, SwiftUI is not going to execute the body of nested. It's just done, so it stops. And this is very important when you think about performance and body executions in SwiftUI. If SwiftUI can guarantee that it's the same value before and after, it will not execute the body. And so let's make it more interesting still. We're going to change this to a dynamic value. And so now if we change hydration, of course, the value is going to change, right? So we change hydration, we recompute a new body with a new form, new section, new everything. And then we have this nested view, and the value has changed from before. It's a new value in there, and so SwiftUI says, okay, you know what? I need to execute the body of my nested view. And so this is how SwiftUI is incremental. It's not really for every single node, but it's at the body level of a view. That's where it becomes an incremental system. And we did not have to write any observation code for this. It happens automatically. The moment we access a state property, a dependency gets added. I think that's really cool because it's so hard to think about these things, but here it sort of is correct by construction. Okay. Let's look at the next example. So I mentioned that I wanted to build a static site generator, and here is a first attempt that I did. My website at some point had, I don't know, maybe 100 blog posts, which was way too slow because it was in Ruby. And so I rewrote it in Swift, and this was kind of what I came up with in the beginning. So we write index.html, we can write a blog function that reads all the files from the current directory and then maps over them with a for loop. And then for each for loop, or for each file, it reads the contents and turns that markdown into HTML. So pretty simple. And so we can run this. And so if we run it, it generates 3 files. If we change one.md, it still generates all 3 files. And if we change, or if we add a new file like 3.md, it still generates everything, right? So this is not an incremental app. And to me, at some point, it became really annoying. I really wanted to have this incrementalness that I get, you know, with makefiles, with SwiftUI, with all of these things. And it's actually not possible to make this incremental with this syntax, because how would you even do that, right? Like, how would you only execute the body of the for loop for a file that just got added or a file that just changed? I don't know a way to do it. But we can use a technique from SwiftUI, and we'll first sort of try to make it work, and then we'll look at how it works later. So we can change this to look more like SwiftUI. So the functions, I replaced them with structs, and the lowercase letters with capitals, right? And yeah, it's very important. And so we'll do more of that. So we'll replace the right with a capital W, right? And wrap all of this inside the body for both the blog and the static site. So now we have capitals there. And to sort of keep the dependency tracking working, we also need to change our read there. And so we're going to write it with a closure. And we're going to say, okay, whenever, let's imagine whenever the contents of the directory changes, it needs to execute that body of read there. Our for loop is also something that we cannot make incremental, but we can steal some ideas from SwiftUI and we can write a for each. And now we could probably build this somehow, right? Like make sure that the for each only executes for the file that actually changed or got added. Let me hide the terminal there. With the read file, same story. We can write this in a nested way, and then the write, when we write it with a capital W, it already looks much nicer. We can remove, like, do a little bit of niceties, because now that we're so close to SwiftUI, we might as well steal more stuff from it. So we can say something like .dir post, which means read from the post directory and write there. We can remove the parentheses here, and we can make index.html the default output name, also maybe at the top. So this is a bit unnecessary, but now it reads a lot more like SwiftUI, I think, very short and very brief. Let's see. Yes. So this is the dependency graph that we kind of want to construct. So we have a static site, and it has a write node, and it has a blog node. And if we expand that blog node, in there, there's a read dir with currently 2 files. The child of the read dir is a for each, and the for each actually reads both of these files. And so now what happens is we can, for example, change to.md, and we can do the same kind of semantics as SwiftUI. So what we want to happen is if we change to.md, just that read file should trigger, and just the write file should trigger, right? And not anything else in the graph. And that way, as we edit our blog post, we can have immediate feedback. We could even somehow refresh the web server or something like that. Now, if we add a new file, we actually want another node there. So if we add a new file, the read dir will trigger. It will now have 3 files, which means for each executes, and it creates a new node there. And this is the system I really wanted to have, and I managed to do the syntax part, but I never really managed to make it incremental. And then at some point I had an idea, and I was able to make all of this work in less than a day. And it supports all of SwiftUI. It supports preferences, it supports the environment, it supports state. It's fully compatible. And I'll tell you more how I did it. But it was really less than a day of work. The thing that SwiftUI uses, the reason why it can be incremental is because there's structs. It kind of replaced functions with structs. And it's the same what we did here. We replaced these functions with structs, with values. We cannot compare functions. We cannot know if something is the same function as before, or the same closure as before. But we can compare values. And so that technique is called defunctionalization. Everyone, or a lot of you have used this, I'm sure, and a lot of you will also not know the name. It's somehow, we never talk about this. There's a great talk called The Best Refactoring You've Never Heard of. And so when I talk to people about this, they're like, yeah, I use that pattern all the time, but nobody knows the name. So replacing your functions with values is called defunctionalization, and it gives you all kinds of benefits, like being able to compare stuff or being able to serialize it, right? You cannot serialize a function to disk, but you can totally serialize a value. So let's do a little bit of defunctionalization ourselves, just to see what it looks like. Here we have a simple content view. We have a state property. We have a text with the value and 2 buttons to increment and decrement. I stole this example from Point Free. So we have these 2 buttons, and we want to make it more testable, right? Like, because that's what the Point Free people do, make everything more testable, and they're really good at it. So we're going to add a method for decrement and a method for increment. And now it's a little bit more testable, right? But not really, because we still are dealing with a SwiftUI view with a state property, and SwiftUI views are really hard to test. I don't even try. I just put everything outside of my views, and then I can test it. But I sort of gave up on testing SwiftUI views. But we can extract this into a view model, or actually a model. So let's create a model here. Now we have a counter model with a value, and these methods are now mutating, and we can change the implementation of our view to use that model. There's a little bit more typing, but we gain a lot of testability, because the counter model is really easy to test. And well, we still need to make sure that our view is hooked up the right way, but it's pretty okay. You can actually mechanically go from a model like this to a reducer like the Point Free people. And reducers are, we will look at that. Reducers are really cool because they will let you test even more stuff. For example, if we call the decrement button, we can compare the model before and the model after, but we don't really know whether the decrement method got called. We can just observe the change. If we want to log which methods got called, for example, or build up a history, a reducer will really help with that. And so the first step is, we were talking about the defunctionalization. So the first step is replacing our functions with values. So we're going to create an enum, and we're going to have one case for each method. Now we can change our decrement to an apply function, and we can switch over the enum value, and in the decrement case do -1, otherwise +1. And this is our reducer. We can just really mechanically go from any kind of model we have to a reducer. It's still called Connor model, sorry about that. But that's, you gain a lot of testability. Again, I'll refer to the point 3 people. They do a much better job at explaining how you can test all of this. But it's a mechanical refactoring. You can always go back and forth. You can also go in the other way and do functionalization, where you replace your defunctionalized program with the functions. And so the nice thing about this is, let's fix the syntax here. We can make our actions equatable if we want to and compare them, right? So we can wrap our counter model in another thing that tracks the actions, and now we can compare the actions. Or we could make them codable and store them to disk if we wanted to, and build up a history that we can always play back. And so this technique is really useful if you want to have more testing. See how we're in time. Yeah, I think we can do one more reducer example. Here we have some code to load image data. And you can see here there's an image, and we have a method to fetch details. So we have a URL that we construct. We get the data using async await through the URL session, and then we decode that data using JSON decoder. We can also load a list of images. Let's see if this works. Oh, I think my presentation broke here. Let me restart it. The presentation is done in SwiftUI, so it's not very stable yet, but I think it's fun. Let's see. Yeah, we lost the state. And actually, that is the problem. We'll do it in dark mode, like just to switch it up a little bit. Let's see, I'll make it a little bit bigger. So we had the static site example, we had the content view. Here we go. Okay, now it's typing again. I don't need to do the typing myself. So we generate the URL, we load the data, and then we turn the data into JSON. And we can also load a list of images, right? Does it still not continue typing? Okay. I think I'm lost there. Okay. Well, I can show this maybe afterwards. Oh, there we go. Okay. So I was thinking, yeah, maybe it's the LLM or something. I don't know. So now we load a list of images. It's exactly the same code, different URL. The second line is the same, and we decode a different type. And these are very, very similar, and also really hard to test, right? Like if you want to test that fetch image details does the right thing, that's problematic. And then likewise for fetch image list. So we can defunctionalize. It's going to be the solution to everything, right? So the first thing we could think of is try to do something like an enum, just like we did before, but this is not going to work. The reason is that the fetch image details returns a single image, and the other one returns a list. So that's problematic, and we cannot encode that in the enum. And so we can use a different kind of defunctionalization, actually the same thing that SwiftUI does, and we can say, well, we're not going to create an enum, we're going to create a struct and then a shared protocol. So we're going to delete this code and then create a struct 1 for the image details with the ID, that's the parameter. And we're going to create a struct for the image list with both parameters in there. Now we're going to create a protocol. So we're going to say protocol resource, and it has an associated type result. And so that will be either the single image or the array. Nice. And so we can do the resource protocol conformance by giving it an explicit result type. We can do the resource conformance for the image list, and there the result type is a list of images, right, an array. And so we're getting closer now. One other thing is the URLs. So here we have the info URL, and the path, the base path is the same for both. And so we could maybe just encode the path and not the main domain and everything. So here, this is the other URL. So let's add a path property to our protocol. And we can add that to the image details, so just a simple path. And we can add that path property to the image list. And because these are values, at any time we want to do something with them, we can just inspect them, test them, we can serialize them, whatever we want to do with it. Let's fix up the code to make this work. So we're going to change this to fetch resource, change the type here. We need to change that URL and include the resource.path. We can change the type here for the JSON parsing, and now we're done. And I think this is really cool because we have a single fetch method with 3 lines that we need to test once. We can add as many resources as we want without having to do async testing. We can just make sure it's the right URL and the right type. So this one can go now. Let's see, delete it. Okay, so that's another example. And this is actually very close to what SwiftUI does. When we write a struct myView, to me, that's a defunctionalized function. In React, you would write functions, but in SwiftUI, we write structs because we can compare them, so that SwiftUI can efficiently make the whole program incremental. So back to this example, I mentioned earlier that I was able to pull this off in a single day and support all of SwiftUI, and I did something really horrible. I built this actually on top of SwiftUI. So my static site, it's the worst static site generator in the world because it depends on a GUI framework. But it was really easy. You just, the write node writes a file to disk. The blog, well, that you get for free. The rule is actually just a type alias for view. The read there creates a file system observer, and the read file does the same thing. The for each you get for free, the environment you get for free, preferences you get for free, all of it. And so it literally was, I wanted to re-implement all these bits of SwiftUI, and at some point I guess under the shower at some point I realized, like, I can just use SwiftUI, why not? People are gonna be upset, but I love it. And it works surprisingly well. It's not 100% correct yet. Sometimes it breaks a little bit, but you can run your app, it generates the whole site, and you make small changes, and it actually is super fast, and it reloads the browser tab and everything. So you know, I think it's kind of cool. So let's do the resources. So these are links for afterwards. This is a really cool paper that shows you how all of these build systems are the same. So spreadsheets, build systems, and all kinds of stuff. This is the talk I mentioned earlier about defunctionalization. I can post the links later as well. There's the talk about how SwiftUI is incremental, the Swift compiler is incremental, both at the package and at the source level. Then this is a super cool website that shows all kinds of strategies for how to efficiently recalculate a spreadsheet. Here's where I first learned about incremental programming, a really cool talk. It's in OCaml. The composable architecture, they use all kinds of defunctionalized stuff, right? Like for reducers and for testability and everywhere. And I think, oh yeah, I need to fix the scrolling issue here. This is the paper that SwiftUI is based on. The attribute graph in SwiftUI is based on this paper. Yes, this is the time to take a picture. And so you can read this. There's actually a tiny mistake in the paper, but it's really simple under the hood once you understand it. It's one of these things that's hard to understand, but when you understand it, it's simple. There's a book about bread baking by Daniel Steinberg, who's also in our community. If you want to actually know more about bread baking, I have very little experience with bread baking. And then here's the static site generator. You can look at it and play around with it. Okay. I think there was all for this slide. Oh no, there is one more button. Is there anything coming? Yeah. Not really. Okay, so if you want to get in touch, you can check out the field guide. I made this last year. It explains how SwiftUI's layout system works. Objective-C.io is the project that I run with Florian together. You can find me on Mastodon or Blue Sky if you want to hang out in the digital and cyberspace. And then I think that's it for me. Thank you.
Okay, so now we'll have questions and answers. I knew it was a sneaky promotion of home bread baking. I knew it from the start.
Yes.
Okay.
Yes, please ask hard questions as well. I love that. Ask anything.
Yeah, first of all, great presentation, like a lot, thanks.
Dziękuję. Dziękuję bardzo.
When it comes to the functionalizing approach and refactoring everything in general, what is your typical approach for edge cases? Because in my experience, there are many approaches for different solutions, and they work on a happy path very, very nicely. But they have very similar case like the resource you had recently, implemented almost exactly the same thing. But I hit the wall when I needed to make a request that did not return value.
Yeah.
So that was the edge case.
Yes.
I couldn't have decodable result.
Yes.
And that's like example, but there is general pattern of edge cases in different places. So do you have like some framework for handling edge cases like that?
No, I don't have a framework, and I don't like. Of course, in a presentation, you can just let the computer type it, and it looks easy. In practice, it's often difficult. Like I did a few implementations with an enum where I should have used a protocol, and it took me too long to realize. Like in that case, where you have something that's not decodable, there's multiple solutions. We created a networking library called Tiny Networking years ago, and there's actually no result associated type, but every resource has a parse function that you feed data, and it gives you success or not, or throws or anything. And then you're super flexible, but it also becomes a little bit more work to test. And so you can do an initializer where your type is codable and automatically generated parse function. But the more requirements you have, the more complicated either your protocol or whatever it is that you do becomes. And no, I don't have a good solution. It's a really good question. I wish I had a better solution, but especially, sometimes you build something, you have the happy path, it works great, and then you get this one feature that breaks everything. And I don't have a good solution. And sometimes it's just a matter of keep trying, and then you find a simple solution, but not always. So no good answer. I'm sorry.
I can see that there are more and more static site generators in our Swift community. Would you have a pitch why to use yours?
Well, I called it the worst static site generator in the world. I think it's the only one in Swift that's incremental. That's maybe one thing. I don't know if it's actually faster. Probably not actually, but it is faster. So the way SwiftUI works, right? Like it builds the whole view tree, and this static site generator does the same thing. I can pull it up in a second if you want to. So it builds the whole website, so that's not super fast. But then actual changes are instant, like because there's very little work that needs to be done, and SwiftUI takes care of the incrementalness. It's absolutely unfinished. I'm not even using it for my own website yet. I needed to get the presentation ready, but I will. I totally will, and I know people won't like it, but I would use something that's more supported if I were you. But if you enjoy it, then why not? Yes. It's not production ready.
Hey, I'm Bart. The question is, how did you make that presentation? Because that was pretty, interactive and looked good, but it had broke. So the question is, how did you do that? And what is it? Because that looks awesome.
Yeah, it's just SwiftUI. And what I did is I took it's also Coco. So I took an NS text view, and in the NS text view, when you do any kind of command, it calls something like should replace text in range with something like that. And so that's a method it calls, and I wanted to be able to replay it. So what do you do there? How do you serialize those method calls? Defunctionalization. So I defunctionalized the method call, and it actually stores it like a whole array with all the operations, and then I could just press play, and it plays it back the array bit by bit. And if your computer is slow enough, the typing is slow enough. And
I saw in the middle that you showed the simulator of iPhone, and
Yes.
how did you put the simulator into the app? Because it was like in the middle with a scroll,
Yes.
like a website.
So it's smoke and mirrors. I don't know if does it still work? Do we still have the screen? So there is a simulator there, and it's not really a real simulator. And also the Mac terminal is not really a real Mac terminal. It's just a SwiftUI view with the environment set up the right way. I don't know if we can get the screen back on. Is there? There we go. Yeah. So it's, let's see. Where do we have it? The simulator. There we go. So it does support dynamic type, but it's not really a real simulator. It's all fake. It's just Mac OS, so we can type. Yeah, and we built all of this because we need that in our workshop app, and so this is actually the presentation we use for our workshop. So there's a lot of really cool stuff there as well about like animations, how that works, and like let's see if I can get this to work. And so there's like all kinds of fun explanations there, and I was able to put the presentation together because we had all these bits lying around already.
Can we access that, or is on
Not
YouTube?
yet. No,
Right.
no.
Okay.
I want to make this into something that people can work with. But the problem with the presentation and also with this is that it's actually really hard to operate this because I'm a really horrible UX designer. The designer I work with made this beautiful, but the interaction I did myself, and I'm really bad at that. And so I know how to operate it today, but probably not next week. But there's all kinds of fun stuff there, yeah.
But it looks very good, so.
Thank you. This is actually in a presentation from, if you look for Pragmamark last year, or the what was it called? The one in Paris. I used it too. And yeah, it used to be called French Kit, and now it's Swift Connection. Swift Connection. There you can watch this if you want to.
Any other questions? Cool. So I think you can catch Chris afterwards.
Yes.
Give him another applause, please.
Thank you.